In this tutorial, I'll be showing you how to model this keyboard in Blender. This video is geared towards intermediate Blender users who are comfortable with the interface and know the modeling basics as they go pretty quick since there's a lot to cover. If you have any questions, leave them in the comments and I'll do my best to answer them. We'll start by changing our units. I pulled apart my own keyboard and took a bunch of measurements to guide our modeling, so we'll set up Blender to take advantage of these numbers. I'll provide the dimensions as we go along. Set the units to millimeters, lower the grid scale to 0.001, and set the clip start to 1 millimeter. Then, zoom in super close. To model the base, add a cube and set up a mirror modifier on the X and Y axis. I used a separate modifier for each because I'll apply the Y mirror later on. Since I know the base is 302 millimeters across, I'll grab the side and move it 150 units along the X axis. I'll do the same thing along the Y, extending it down by 53. Then, I'll move everything up by 1 just to have it level with the ground plane before moving the top face up 26. To create the inset portion, turn on clipping for both of the mirror modifiers, extrude the top face, and leave it in place. Then, move the new face inwards along the X and Y by 5. Extrude the newly inset face again and move it down the Z axis by 10. Shade it smooth, turn on auto smooth, and add a level 3 subdivision modifier. From here, you have a couple options for defining the shape of the base. If you want a uniform shape that's easy to control, add a bevel modifier before the subdivision and set the limit method to none. Tone down the bevel amount and increase the segments and you'll have something that looks pretty decent. I would advise not turning on harder normals though, as they'll create some hard seams along the corners. If you want more control over the shape, you'll need to use support loops instead. It requires more work, but it allows you to adjust the shape to your liking. For instance, if I want a rounder slope on the sides, I can drag these edges down. I can also tighten up loops in places where I want a more pronounced corner. Play around with it until you end up with something you like. If you think you'll want to change the shape later on, now would be a good time to make a backup copy as we're going to apply the Y mirror modifier. Dissolve the edge that the mirror created in the middle. From here, we'll give our keyboard its slope. With X-ray mode enabled, select all the top vertices at the front and move them down the Z axis by 9. Then add a plane and scale it up to 108 millimeters so it's the same width as the base and move it over to the side. With both objects selected, I'll go into edit mode. If you look real close at the side of the base, you'll notice the top runs flat for a bit before it slopes down. I want the slope to be consistent all the way across, so I'm going to use the plane we created to help with the alignment. Snap the plane to the outermost vertices of the base, then extrude it so it's easier to see from side view. With just the base selected this time, go to edit mode and turn on edge snapping and have it snap to the active selection. Go down the side of the base and snap the vertices along the Z to the edge of the plane. To ensure there's an active selection, I'll left click to select a vertex first, then hold down shift and box select the rest of the vertices. Be careful with vertices that are really close together but aren't actually in line together, and make sure you account for the entire vertical stack of inset vertices as well. If for some reason Blender decides to be weird and not snap correctly, you can always move the points by hand. When you're done, you should end up with something that looks like this. Delete the plane if you want. And just like that, we've modeled the base. Easy peasy lemon squeezy. Let's move on to the keycaps. We'll once again start with the cube that has an X and Y mirror on it. I also moved it up the Z axis by 1 so that it's level with the ground, but I did it in edit mode so that the origin stayed in place. Extend the cube by 8 on the X and Y axis and extend it by 9 along the Z. Add 3 levels of subdivision, shade it smooth, and turn on auto smooth. Add a plane that's 18 millimeters in size. The subdivision modifier shrunk the silhouette of our cube significantly, so we're going to use the plane to size things back up. In top view, move the vertices until the edge of the shape lines up with the plane. Then, apply the Y mirror and dissolve the middle seam. Rotate the plane 90 degrees along the X and extend the top part by 2 so that it's 11 millimeters above the ground. In front view, move the top of the cube until it's lined up. After that, you can delete the plane. Move the top inwards by 3 along the X and by 2 along the Y. At this point, make a duplicate copy of the key and hide it for now. We'll use that to model the spacebar later. To create the key's curve, move the front vertices down 1, then move the center vertices down by 1. From here, delete the bottom face and add support loops to shape the key. If you want, you can add a solidify modifier at this point to give the keycap some thickness, but I'm not going to do that in this case since I'm not showing the bottom, and I don't want to increase the face count for things that aren't going to be seen. We'll make a backplate for the RGB lights to shine through by duplicating the top face and separating it out into its own object. Then, move it down the z-axis by 0.07 millimeters so it sits just under the surface. You may need to go even lower depending on how you shape your keys. This is something you can always fine-tune later on if you notice the backplate's clipping through. Parent the key to the backplate, keeping the transform. With this, we can very quickly make any other key on the keyboard. Select the keycap and expand the selection with Shift right bracket to include the backplate and duplicate it with Shift D. The first key I'm going to make is one with a reverse slant. Looking at the side profile of my keyboard, I notice that while the fronts and backs of the keys are the same, some of the tops are slanted in the opposite direction. To reverse the slant, just move the high points down 1 mm and the low points up 1 mm. To make the different size keys, create another duplicate, making sure that you include the backplate and refer to the dimensions to see how much you need to extend along the x-axis. With the exception of the spacebar, that's the only change between all the keys. For example, to make the backspace, I just have to move the vertices along the x by 9.5, making sure I grab the backplate vertices as well. To make the spacebar, I'll take the duplicate I made and hid away earlier, delete the bottom face, and move the vertices along the x by 50. I'll add a loop cut along the middle lengthwise and move those top middle vertices up by 1.5. From there, you just have to add support loops to shape the spacebar as you see fit. Once you're done, you should have something like this. I used the normal slant for rows 1 and 2 and the reverse slant for rows 3 through 5. I also organize my keys into collections by row, as this will make life much easier when I have to hide and unhide things later on. To figure out the position of the keys, I just did a little math. I know the size of the base, the keys, and the distance I want to leave between the edges, and with that I can calculate where the leftmost and rightmost keys should be. I'll edit the transform and voila! My escape and backspace keys are now in place. Here are the dimensions for the rest of the keys. By the way, if you encounter some visual glitching where it looks like the backplate is z-fighting from some angles but it doesn't show up in the render, lower the clip end amount and it should go away. With the left and rightmost keys in place, we can quickly position all the small keys in between without having to manually type in their locations. Using a bit more math, I calculated the gap that should be left between each key. From there, I selected the leftmost small key and the backplate, hit Shift D to duplicate it, locked my movement to the x-axis, typed in the distance it needed to move, and hit Enter to place it. Since I did all of that in a single action, I can hit Shift R to repeat it and create the rest of my keys. I'll give you the position of the first small key as well as the distance it needs to be moved. I'll also provide the location for all the keys in row 5 as well, since the spacebar interferes with this technique. With the keys in place, it's time to add the text. Unfortunately, they have to be added one key at a time, so throw on some good music and get ready to grind it out. Select a key, hit Shift S and move the cursor, then add text. Drop the radius so it isn't enormous, move it up the z-axis so you can see it, and type your letter. Change the font into something that looks nice in the Object Data Properties panel. Right-click the text and set the geometry to origin. The character should now be centered over the key, and you can make whatever adjustments you like. For keys with multiple characters, you can try having more than one character in the same text object and manipulate the alignment and line spacing to make it look nice, but how well that works is going to depend on which font you choose. With this font, I ended up separating each character into its own object. Now while the text has to be added one key at a time, there are other actions that you can batch. Here, I have characters I typed out for the first row. I can select them all, making sure I have an active object, and change the font. Then I can hit Ctrl L and link the fonts to text to have the same font apply to all the other objects. If I want to adjust any numerical fields like the spacing or font size, I can type in the number and then hold down Alt before pressing Enter to have the change apply to the entire selection. I can also set the geometry to origin for multiple objects at once. To make the Windows key, I added a plane, scaled down one end, added some loop cuts, inset faces, and deleted the faces in between. For the backspace arrow, I used a plane and a cone with 3 vertices. I deleted the top faces of the cone, leaving me with just the bottom. Then I positioned the arrowhead and subdivided the connecting edge twice. I snap the new vertices to the plane and merge them, making it a single object. To center these shapes on a key, you can send the cursor to the origin of a key, send the shape's origin to the cursor, then send the shape's geometry to the origin. With the text added, we can position them closer to the keys. Select the text and hit SZ0 to align them along the Z-axis. You'll notice the font objects went black, and if you try to extrude the font right now, nothing will happen. To fix this, open up the Transform menu and set the Z scale back to 1, making sure to hold down Alt before you hit Enter so the change applies to everything selected. Then I'll snap the text to the face of the keys. From there, I'll extrude the font so it punches through the keycaps. Make sure you extrude far enough that the entire character goes all the way through, as we'll be using these with the Boolean modifier. Extrude through any objects you created as well. Once that's done, I'd advise making a backup of everything, as we're going to be applying the modifiers. If you decide you want to change anything or found out you made a mistake later on, the backup makes it so you don't have to start from scratch. With that out of the way, I'm going to hide the backplates. Start by hiding everything but the backplates and keys, select everything, then go to Select, select More/Less, Child. If you wanted to raise or lower your backplates, by the way, this is how you select them all to do it. Anyway, hit H to hide them. Unhide the text and select them. With an active object selected, right-click and convert to mesh. If you have multiple characters per key that you created as a separate object, join those characters together with Ctrl-J so that you only have one object per key. Unhide the keycaps, select everything making sure you have an active selection, and hit Ctrl-A and choose Visual Geometry to Mesh to quickly apply all the modifiers. Add a Boolean modifier to any key, and with that as the active object, select the other keys and copy the Boolean over. Then unhide the text and go through each key, selecting the character as the Boolean object. Once that's done, hide the text and you'll have something that looks like this. Notice that some of them didn't cut out properly. If this happens to you, the first thing I would check are the normals. If I turn on face orientation and look at the characters, you'll see that the Windows logo and backspace arrow are inside out. We can fix this by selecting them, going into edit mode, and going to Mesh, Normals, Recalculate Outside. My C key is still messed up though, and the only fix I found for this was to move it down slightly. I have no idea why that works, but hey, there it is. If you use the Solidify modifier, you should be able to see through the holes in your keys just fine, and you don't need to follow this next step. If you didn't use Solidify, you'll notice the Boolean created new faces where it cut, so we can't actually see through the keys. To fix this, select all the keys, go to Edit Mode, switch to Face Select, and select all the faces. It's very important you use Face Select and not Vertex or Edge Select. Go back to Object Mode, and with an active object selected, hit Ctrl-A and select Visual Geometry to Mesh to apply the Boolean. It may take a few moments for Blender to work, so give it some time. When it's done, head back to Edit Mode, and you'll see the new faces aren't selected. Hit Ctrl-I to invert the selection, delete the extra faces, and now you can see through the keys. Now you can hit Alt-H to unhide everything and see what it looks like. To match up the slope of the keys to the base, I used the measuring tool to find the angle that I had to rotate. Drag out a line parallel to the slope of the base, then click and drag anywhere in the middle of your measurement line to create an angle. Have the top line run parallel to the ground, and you should have the angle the keys need to be rotated. Select a key in the third row and send the cursor to it. Select the rest of the keys, making sure you still have an active selection. Set the pivot point to the 3D cursor and rotate along the x-axis whatever angle you measured out. Then I set the top of the first row to be 37mm high on the z-axis. I did this by having the bottom sit at 25mm. If you prefer to use a visual guide, you can use the grid or create a plane that's the correct height and line up to that. My material setup was very simple. For the keys, I just changed the base color and used a scaled up noise texture as a bump map to give the keys a matte painted look. For the backplates, I used the white material and turned up the transmission and transmission roughness to make it look like transparent plastic. For the base interior, I used another white material with the roughness set to 0 to help it reflect the RGB lights. If you want to apply the same material to multiple objects, you can quickly do so by selecting everything, making the object that has the material you want the active object, hitting Ctrl-L, and selecting Link Materials. Last but not least are the RGB lights. I went through the trouble of adding a point light underneath each of the keycaps by moving the 3D cursor around, similar to how we added the text. It's a little tedious, but I wanted the fine-tuned control. If you want an easier way of doing things, you might be able to get away with making the bottom of the base an emission plane instead, so you don't have to deal with so many lights. And there you have it. If you have any questions, post them in the comments and I'll do my best to answer them. If you post your render to Instagram or Twitter, tag me in it because I'd love to see your work. Links to my socials are in the description.